direction.
Where are we going?
We're going to where our instruments are deployed. This is the start of what's called the K transect. Measurements here were instigated like early 90s, so have been going on, late 80s, so going on for over 20 years now. And this site is known as S10.
What does that mean?
S10, it's just a random number. There were 10 stations deployed on the K transect, the Kangalussuaq transect. And a weather station at each one, and a position of it. So I think the measurements pretty early on were pretty basic. But since then we've got 2 automatic weather stations. We've just put in this snowpack analyzer. I've had a precise GPS station here for 5 years now, which we're heading to, and so there's quite a lot of detailed measurements going on at this site, and really the reason why we're so interested in it is because we're so high up on the ice sheet here. Nothing really should be happening.
Right.
This is like our litmus test, our control site. But sadly, like all plans, they don't quite work out, and we're seeing bits of movement. We're seeing quite a bit of melt here, especially in warm summers. And so actually this site is becoming more and more interesting, because it's really that, you get this idea about the canary down the mine shaft. This is one of those sites that's super sensitive. It's just above the equilibrium line.
Can you explain what that is?
Equilibrium line, it's just the point on the ice, it's a hypothetical point on the ice sheet where the amount of snow that's falling and the mass that's moving in is completely equaled by the amount of melt coming off. So it's a point on the ice sheet. It changes with time, it changes with climate change, but it's a point on the ice sheet where melt equals accumulation. So it's a very important hypothetical idea of a place. And of course, as the climate warms, the ELA, the equilibrium line, moves further and further into the interior of the ice sheet, meaning more and more of the margin is exposed to melt.
Yeah, and so you've been measuring here 10 years or 5 years this
5 years here myself, but the measurements were started here over 20 years ago. So
in 20 years...
It's the longest record in Greenland in the interior, so it's quite an important site.
Yeah. So this equilibrium line has moved this way for
years. It's moving up glacier into the interior. It's
in 20 years, how many meters?
Well, that's a good question. We usually talk of it as an elevation, not necessarily a horizontal distance. Of course, a couple of 100 meters the ELA has risen.
And an elevation?
That is in elevation. In terms of what it means in terms of the horizontal movement of the ice sheet, or the bigger the margin, of course it varies a lot year to year. We have, like the rest of the world, we have hot years and cold years, and 2010, this site here experienced a really large amount of melt. So in that year the equilibrium line was somewhere up here, if not beyond.
Really?
Yeah.
And that's what you'll be able to measure in some of these instruments with that ice layer, right?
Exactly, yeah. So Hurst, who's taking the ice core, that melt layer is really very well defined in the snowpack here.
So this was meant to be, well, let's keep walking to your...
Yeah, we're going to this one here.
But 20 years ago, this was just a control station.
Yeah.
And now it becomes like the major subject of your research.
Yeah, it's there's a lot of people now looking. Obviously, we know that the margin of the ice sheet's melting really quick, and it's lowering really fast. What we're really looking at is to see what that signal means in terms of the propagation of that signal into the interior ice sheet, whether or not the whole ice sheet is drawing down and being kind of sunk into the ocean, if you want.
But explain to me, what is the meaning, what is the importance of an equilibrium line for research?
Well, it's it's like your bank balance, right? It's the point where you draw equal, right? So if you've got a healthy bank balance, you're in credit, you've got more money coming in than going out, everyone's happy, right? So the ELA, basically as the ELA moves up, it means more and more the ice sheet is going into deficit. The ice sheet's spending more than it's gaining, and that actually means that you're losing mass from the ice sheet as a whole, and that sea levels are rising. So that's why it's important. we want this ice sheet to be in equilibrium. Sadly, it's not, especially over the last 10 years or so.
But it's always been the case that in the summer the ice melts, right? Yeah. Otherwise, because in the winter it grows, and then if it wouldn't happen, then the ice sheet would be really big and would keep extending.
The whole system is really dynamic. It's changing all the time. You come here now, there's not much sign of melt. In fact, it's bloody cold. But the point is, you come here in 2 months' time, the end of June, July, and the temperatures will be above zero. It'll be pretty balmy here compared to now. Yeah. And that's the melt. But as you go lower down on the ice sheet, more and more melt is occurring. So yeah, this is a seasonal process. Winter, the whole ice sheet freezes up. Summer, a lot of that area becomes exposed to melt. What we're interested in is a long-term story. Yeah. That's why it's very important to come to these places that have been going for 20 years, because that's where we see the long-term trend and the long-term record.
Yeah. So these instruments that are here,